Okay. Hello, everyone. I can't really see any of you because I lost my glasses somewhere and I haven't had them for months. So you're all blobs, but I'm sure it's great. Okay. So about me, my name is Stephen Kampen. I'm a developer at Wrangle.io in Toronto. I started writing software in 2009. I mentioned the year because front-end development was a very different thing back then. And I didn't really enjoy it. It seemed to me that the front end was a second-class citizen, and because of the lack of tools to do anything really good or really of any real complexity would take far more time and money than most were willing to allocate. For this reason, I tended towards working in the back end. It was only in 2013 that I took another look into the available front-end tools and realized that everything had changed. I immediately switched my focus and have been building Angular and even React apps ever since. So now onto Augury, and I have slides here, but they're really ugly, so I apologize for that. I just added some graphics in there, so in the last 30 minutes. So yeah, these are all slides though, legit. So first up, I want to know who develops Angular applications of people here? Most people. And who's heard of Augury? Oh, a good amount of people. Who's used Augury? Less. Who still uses Augury? One guy. Okay, that's good. That's good, I think. So, the history of Augury. Augury is an open source tool for debugging Angular applications started by Wrangle in September 2015, formerly codenamed Batarrangle. It was demoed in October at Angular Connect 2015, and since then it's been endorsed by Google as the official Angular debugging tool and benefits greatly from their continued feedback and input. During the beta release and release candidate stages of Angular development, the stability of Augury took a bit of a backseat in favor of keeping up with everything. Since then, though, we've been concentrating on improving that, and the current build has become stable to the point that we are able to start really thinking ahead about features. Importantly, we've only ever had a skeleton dev crew on Augury, so we're trying very hard to be open about contribution from the community. If anyone is interested in helping out, I'll be talking a little bit about that later. But we are very open to that. So, what is Augury? Philosophically, Augury is a runtime inspection and visualization tool and runtime debugger, not a coding or compile time debugger. So we're not trying to build an IDE here. I'm not trying to allow you to build an app through this, but only use it to have insights about your app that'll help you build it the way you usually would. So literally, it's a Chrome extension that exposes a tab in the Chrome developer tools where you get a handful of different ways to inspect the anatomy of and interact with your Angular application. It's written in TypeScript, built with Webpack, and the UI portion is actually an Angular application itself. So how can Augury help me? Augury's usefulness comes generally in two forms. First, it provides insight into the configuration of your application. This includes things like seeing which ng modules are imported, which components are available, which injectables are provided in the app. This is useful for several reasons. You could be looking at an application for the first time, or the first time in a while at least, and you want to get a broad sense of the size and shape of the application and its dependencies. It can also serve as a reminder that you haven't imported or declared a particular module or component, and that's why what you're writing in a template isn't having the effect you expect. The second way that Augury helps you is that it allows you to debug, meaning inspect and interact with the application at runtime. This includes easily visualizing a complex or deep component hierarchy, inspecting component state, editing component state, and otherwise interacting with components. I'm sure you can imagine that these features could be helpful in many situations, but in just a minute, we'll do some concrete demos for clarification. How to start using Augury. Now, this is pretty simple. I was going to do a live demo, but I didn't realize I'd have this kind of resolution here.
Better?
Yeah. Okay. Okay. So this is going from scratch. If we go to search Chrome Web Store Augury. Find where I am here. So basically install it like this, add the extension, start up an Angular application, which I have here, make sure it's in debug mode, and then open the inspector tools, and you'll find over here is a tab called Augury. You can just drag that anywhere you want. That's Augury, and for some reason it's not working, but let's ignore that. There we go. So that's Augury. Let me go back to where I was. Okay, so how Augury works. At a high level, Augury consists of two parts: a backend, which is a content script that gets injected into the execution context of the inspected application, and a front end, which is an Angular application that makes up what is seen in the Augury tab of the dev tools. So in this graphic down here, the tab we just saw, that's the UI, and then the backend is a content script injected application that communicate like such. The backend script uses some Angular debugging functions to pass information from the current application and provide that information to the front-end application, which renders it. Actions requested on the front end are transmitted to the backend, where the actual interaction with the application is performed. So now I'm actually going to do some feature demonstrations, and this is all hopefully going to work straight out of the box as well. So, okay, features. First off, most important, we have a dark mode. I don't actually use that, so let me turn back off. Okay. Okay, so first, this is a component tree tab. So first thing that pops up, you'll see this, and that's the default screen, obviously. This is, here on the component tree tab, we can inspect and interact with the currently rendered components. In the left pane, we can see the currently rendered components in a tree format, and hovering over them will highlight them in the application. You can also use the search bar to find a component by name, so I can select it by name. So it's selecting the first one that matches that. If I want to do that, I'll select the next one called message something. Or you can select it with a mouse using this tool here, which works a lot of the time. There you go. Okay.
I want to zoom in on that.
Oh yeah? Change the resolution again? There you go. How's that? Okay, so once a component is selected, you will see further information about the component in the right-hand pane. That's over here. In the first tab called Properties, we can see lots of specific information about the component instance. We'll also see the change detection configuration, the value of, these are the change detection configuration there, and the value of any instance properties on the component. So here, this toggle component, you can see it's got a label called off, which is a little bit confusing, and a Boolean state, which is also confusing. But that's a Boolean component instance property. Just trying to find a good example of the next feature, which is here. So in this form, this is instance provided. So anything that's provided by a component, either explicitly in the component configuration or implicitly through the use of different directives, will be available here. So here you can actually inspect, this is a form input, obviously. We'll actually look at the input itself. You can actually see all the things that you would see or that are built up as a, by the forms module. So this is obviously really helpful when working with forms especially. So that's a relatively new feature in the last couple of weeks, but it does prove to be pretty helpful. Now, as suggested by this little message here, we can also check out this in the that element, the selected element in the console. So if I just print A there, I actually get the debug element representing that one. So you can always select the component and see the unpassed information this way. So the component instances will be there if I select one of these. So that's the message board component instance. You can see the same property there that if we go back here, we see is here. Okay, so now I'm just going to demo changing the state and interacting with the component. So this is actually doing what you would actually, the logic of your application can do as well. So you can, before you've written the logic in the application, you can test it out perhaps by coming in here. So this message over here, Jumbo Shrimp, is a property on that instance. We can change that to whatever, and that changes in the application runtime. So if I also do that in the application, it also changes back in Augury in real time. So that is just changing a property. We can also emit an event in here. So this count event, and I'll show the source of this, which is another feature we have here. I can look at the source here, and the count event property is an event emitter. So if I go back to Augury, and that just emits a number, if I emit that, it will actually do what it's meant to here. So incrementing here will emit the current count up, or I can just override it by putting anything in there, and it goes to the parent as it would usually. So the injector graph. The other useful feature for understanding component hierarchy and anatomy is the injector graph. On this next tab, this is basically a visual representation of the component or injector hierarchy, of the dependencies injected by each component, and of the origin of those dependencies, i.e. where they're provided. Now I'm going to find a better example here. This is the kitchen sink application, which we use in our, is actually part of the Augury repo right now. We're kind of redoing that. Let's refresh it because we installed Augury. So if I look at the injector graph now and select the component 5, this shows us, there's a slightly more complex component hierarchy. So the left side here is the actual components and their hierarchy, or the root here is the root injector. Each other blue node here is referring to the component and the injector that component has. So the lines that come out are the things that are actually injected into that component. So you can see here, kitchen sink, that's the app component, the root component. It has two things injected in it, router and activator route. And if I look at, just for fun, if I go up and select the kitchen sink thing, I can look at the source of that, and you'll see those two properties injected right there. Roll back down. Okay. Back to component 5. So component 5 is an example of slightly more complex. You can see all the other up the chain, all the other injectables here, provided injectables, are coming from the root injector, which means that they're provided at the, in this case, at the app module level. So that's coming from the root injector. Down in component 5, we actually have two different circumstances here. So service 3, in this case, is injected, according to this blue line, by component 2. Service 4, according to the legend here, is self-provided. That means that component 5 itself provides that and then injects it. So we can show that by looking at the source. So we can see it provides service 4 and injects it. And then just to prove also, so component 2 apparently provides service 3. If we have a look at that, it does indeed. So looking at that graph then, you can always track back, and this is a pretty contrived scenario obviously, but you can always look at and find out pretty quickly where something is coming from. Next, the router tree tab. This is actually running an old version for some reason. Ah, of course. I'm actually releasing a new version today, so that version from the web store is a little bit old, and I'm showing you something that's a bit newer. and we'll cover how to do that in 2 seconds. Okay, I'll fix that in 2 seconds. So this is a router tree tab. This router tree tab obviously shows you, pretty straightforward, it shows you the currently loaded routes in the application and some basic context about each route on hover. So you see there the path and which handler is in which component that's actually pointing at. This also handles lazy loaded routes. So if we go over here and actually load the lazy loaded module, you'll see that update straight away. So it's the currently loaded routes, not obviously all routes, because they can be declared and even completely asynchronously fetched modules. So you'll only see what's currently loaded. And that one's pretty simple. Now I'm trying to find this other. Getting a quick demo here. I'm going to cover all this in 2 seconds, but I just had to recompile. Oh, this might have something to do with it. I have 2 installed. Okay. There we go. Excellent. So the next one that I want to show you is ng modules. So this is a very new feature. It's not even in the web store yet. So this evening it will be in there. So this feature is actually just released today. It was about to be, and it's the first step in the direction of a visual interface to the application configuration. What it is so far is a list of all imported ng modules, starting with the bootstrapped one, which you can see here is app module. Is that a good size, or should I make it a little bit smaller? Okay, I'll make it bigger. Okay, so within each module section, this is a module section, say all that. Within each module section is a breakdown of the main configuration of that ng module. In order here, they are the modules which are being subsequently imported. So from the app module, we import these 5 here rather. The exported modules is the next one. The providers declared at the module level, which is these, and that includes tokens. So anything that's imported at that level is here. The declarations, or this is actually just at the moment just components, not pipes, so not all declarations, but I think that's what it'll be in the future. So you can see just for that's all of our own components that we've declared in the app module. And if you broke your application up into other modules, then you would see further breakdown of that in subsequent sections. And then this last one here is providers in declarations. So these are things that are provided within those components in these direct declaration section. So as we looked at that before, we saw that a couple of the components were actually providing, as in overriding service 3 and service 4, because those are also provided here in the at the app module level, rather, the app module level. So this is ones that are provided within the components which are declared by that module. So you can see here the imports, we import those 5. You'll see each of those as we go down here. So all the further information, the router module, you'll see the declarations it has, etc. So that's pretty simple, that tab, but we really want to take it a lot further. So that's just the first iteration. Okay, so that was the live demo. Go back. So development challenges. To be able to integrate so closely with an Angular application without requiring any modification to the inspected application was understandably a bit of a challenge. Additionally, packaging this tool as a Chrome extension turned out to be another due to the nature of communication between different execution contexts. I'm going to quickly cover some of these issues and outline how we made it all work. So Chrome extensions. I'm sure many of you are familiar with the caveats around Chrome extensions, so forgive me if this is old news for you, but basically a Chrome extension runs across a couple of execution contexts. So it's content scripts, background scripts, the UIs that you have in the DevTools tab, and I'm sure there's even more. The communication between them is limited to inter-context message passing, which means serialization and deserialization. How does Augury integrate with the application? Augury's backend is bootstrapped via the extension's content script, which runs in the inspected application's execution context. So it's running inside, it has access to the global context of just as the same as the application that's being inspected. Using a very convenient, globally defined Angular utility called getAllAngularRootElements, we're able to subscribe to the ng onStable event for each root element. ng zone onStable event, rather. Now Augury can react to any new ng zone cycles and repass the state of the application. So that's any changes within the root elements or their children, because change detection is nested like that. Another caveat of this content script is that in this execution context, Angular is already provided by the inspected Angular application. So our backend, which is also injected by the content script in the same execution context, should not be compiled with its own Angular source. This backend then, which requires considerable knowledge of Angular, cannot import any Angular modules and is limited to artifacts that are globally defined, like ng. I'm not sure if you guys have used this, but if you go into any Angular application, you can use ng as a globally defined object and has a bunch of helper things on there that you can play with. So we use that a lot in our code to ng probe, for example, is basically how we get the debug element from a raw element. ng core tokens, we use that as well. And the getAllAngularRootElements, which I described before, we use that. So our Augury can actually access them because they're in the global context, but it can't actually, in our code, we don't, or in that part of the code at least, we don't have access to Angular types to compare things, for example. So we have to do a bit of, there's a few tricky things we have to do just to know what we're even looking at, I guess. So a bit of hoop jumping. So message passing is the next challenge. Now that Augury is able to pass the application state, we have to deal with the issue of efficiently communicating the information to the front end. Performance is more of an issue here than you might think, particularly because of the nature of inter-context message passing, specifically that all messages must be serialized and then deserialized. Further than that, Augury uses a Chrome extension background script as a message buffer, which means that the serialization and deserialization actually happens several times. This isn't a problem for small messages, but the time for sending larger messages, like our component tree message, which contains the past information for the whole rendered application, quickly passes any reasonable threshold when using this mechanism. And this is happening on every ng onStable event. So that's any change at all of any sort. So it happens quite a lot. The solution is twofold. So part one, we make the application state object diffable. So this is like really a pretty simple one, obviously. So we implemented a diffable component tree structure that allows us to calculate and send only the changes after each update instead of the whole state again. Second, we created an alternative message route using the handy Chrome developer tools, inspected.eval API. How this works is that for certain larger types of messages coming from the backend, instead of sending them through the message passing API, we instead add them to a globally accessible queue in the backend execution context. So that's the backend that's running in the application, inspected applications context. It puts attaches its own function to the global scope called something like drain queue. So that queue then is accessible by something that knows about that existing in another context, as long as we use this inspected window.eval API. We then send a small message by the usual mechanism to tell the front end that messages are waiting. Then the front end, using this inspected window.eval API, which can evaluate any code within the inspected window context, reaches in and collects any messages available. While the result of that eval call still must be serialized and deserialized, it's only going to happen once now as opposed to several times. So you can see that illustrated in this diagram, which I did steal from another presentation from someone I don't even know on Augury. It does really good graphics, so I thought, wow, I can't let them outdo me. So the next is router resolution. So this is something that was only recently solved thanks to Victor Savkin, and by recently I mean it's going to be released tonight as well. Thanks completely to Victor Savkin on the core team. The issue was that there was no way for Angular to get a reference to the router if one was used. So the developer is required to inject the router into the root component using the property name router. You'll see that here, this little snippet. So that actually had to be done. It's outlined in our README. But yeah, it's just really not favorable. It was not easily communicated to users. So Augury would actually look for it in that spot by finding the component instance. If it was there and it was of type router, then it would actually use it. But yeah, it really wasn't great. So this was not easily communicated to new users because, believe it or not everyone reads the README completely before starting out. So thanks to Victor, logic was added in the core so that the router type would be registered on ng.core tokens, which is, again, globally accessible by us. So we then had reference to the type, and we could use getting a reference to the injector also of a root component. We could basically get reference to that router. Okay, and that was the end of the challenges. Oh, there you go. So yeah, I will mention that's going to be Augury 1.2.8, which will release tonight. So you will need these versions of those three things to actually have that work. But if you do, it'll work automatically. Okay, so this is how to develop Augury. This was originally going to be some slides, but then I guess we decided I'd just do it live. So let's hope all that works fine. So I don't know why Spectacle doesn't work anymore. Hey, excellent. Okay. So we're going to start from, this is, assume you've cloned the repository, which is a Git repository. You should be able to do that. We've run npm install because I don't want to test that right now. But this is building and installing the application, the extension locally. So we're going to use one of these as an example. Right now, Augury exists. So I'm going to remove it. I'm going to turn off developer mode. So from scratch, open up Chrome extensions. Just run npm run build. That's after npm install, obviously. And this just takes 10 or 15 seconds. Excellent. So we'll see the build targets there, the front-end application, the content script, the channel.js, which is a background script that is a message buffer, ngValidate, which is a script you use to actually check if Angular exists in the inspected application. This is just for setting up the tab, and backend.js, which is the one that is actually also injected into the application context. So to load that then, we just enable developer mode at Chrome extensions, click on load unpacked extension, and just select the Augury directory at the top level. And there's a build directory within there, but at this point you just select the Augury top level thing. So then you'll see this here, ignore all of those, totally fine, awesome. And that's how you load one of these extensions. Now, if we close this, refresh, open it back up. That's Augury running from that build we just did. And there is no router here, it's not broken. There's no router in this application. And that's that. So next, building a CRX. This is actually building a CRX that you can, just like would be done in the, is done in Circle CI every time we submit a PR. But you can do it locally just by doing npm run pack. Do the same thing here. Done. And now you'll see inside the directory now is augury.cx and augury.crx and augury.zip. So to load one of those, just grab augury.crx, go over here, and drop it into Chrome extensions. Click add extension, that's done. And you would disable that one or remove it. Now, you can tell because it's over here, that's Augury now running from the CRX. And it's that easy. Just another thing, if anyone, not sure who would actually try this out right now, if that's going to happen, but if you are reloading from source, so say we go this one here, remove the CRX one, say you do a rebuild here, you will have a reload thing here in 2 seconds, I believe. That's really strange. Oh, it's not enabled there. Okay. So when it's enabled, you get this reload thing here. So every time you make a change here, you rebuild, hit reload there, then go over here. You might have had one open already. Let's look at one that is, no, it's not. Usually you have already Augury open. So the way to kind of ensure that you're running the latest version is to just close that, reload the page, then open it again, and then you're running the latest one. And that's basically how to develop it. Pretty straightforward. So next is what we want to do in the future. So we have a few more common sense improvements lined up and also some grand ideas. Support for lazy loaded ng modules in the ng module tabs, in the ng module tab rather. Adding further context about existing provided injectable instances, not just types. So obviously at the moment we're trying to, we don't really say anything about an injectable instance in the, I mean, there can be many injectable instances. We're showing provided types and which modules they come from, but they can be overridden at any level down the injector chain. So we want to obviously have some way to look at those instances very easily from the injector tab, and maybe also see a listing of them and a listing of maybe components of different types, just to see, maybe get a count of components. So we want to add that to the ng modules tab and the injector graph. Also, this is a bit of a grander one, provide some visualization of component lifecycle events like BatScanner does. So I'm not sure who's familiar with BatScanner. Could raise his hand. That same guy, okay, he knows it. BatScanner is really cool, actually. It allows you to, it actually requires that you make some change to your application. You include an npm package, BatScanner, which then hooks into the rest of your application, all the lifecycle events, and then can give you a graph, a really nice graph about how things are starting up and being removed, everything. So it's really handy for debugging, obviously performance. You can get an insight into that part of your application very easily. So we're looking at potentially doing something like that, or even integrating BatScanner, but that's still just an idea at the moment. Then there's native script support. So this is still just an idea as well, but obviously there's a lot that, with a bit of reworking, we could actually apply a lot of this. We could possibly build instead of instead of having it as a DevTools tab that works on another tab, as in the window, we could potentially have the same interface to just available on a port somewhere and have it working on a native script application. But that is still very early idea. Any suggestions, feel free to bring them up now or start a discussion with us online. So if you want to check us out online, that's the GitHub address, and we've just published today some new Augury guides and other things. Actually, I'll just show you this. So here we have actually a few demos, a bit of what I covered now, and actually a bit more. So yeah, augury.angular.io is good to check out. And that's Q&A.
And actually, I think we're going to hold the Q&A for the end of both speakers, if that's all right. So yeah. Thank you so much, Stephen.
You're welcome. Thank you, guys.
All right, and let me just gauge the room here. Do we want to take a 5-minute break before the next speaker? Yes? Yes. Okay, we'll take a 5-minute break, and then we will resume.
Can I just say one thing as well? We've got a few other guys from Wrangle here tonight. If anyone wants to come talk to us, learn about Wrangle, that's great as well. Come over. There's 4 of us here, so yeah, feel free to.
All the way from Toronto. All right, I think we're about ready to resume here. I see a couple people out getting food still, but we'll go ahead and get started. So we're going to continue this evening's Aussie invasion with Andrew Henry, who we're very lucky to have him with us today because although he's a software engineer and he builds things for a living, he's also relatively famous, I would say maybe. He recently gave he sang a song at the Hollywood Bowl to about 1,700 people. So
not by myself, in a choir. There were, and don't worry, I'm not going to sing tonight. So just relax. Unless you want me to, I do request. I don't.
And when he's not singing, he's working at NASA. So I wanted to introduce Andrew Henry, and thank you so much for coming.
Thank you. So what do we have to do to project the slides? Oh, yeah, there we go. Sweet. Okay, yes, this guy's going up here. And he's going to go, yeah. Cool. Yeah, thank you for everybody for coming along and showing enough interest in this project to kind of listen to me talk tonight. Can everybody hear me okay, by the way? I think the mic's working. As was mentioned, I work at NASA, which is quite close to here, NASA Ames Research Center. And today I'm going to talk about one of our software projects. I'm a software developer over there. The project that I'm working on at the moment is called Open MCT. It's open source mission control software, essentially. So we're sort of trying to build out the next kind of generation of mission control software. It's not necessarily just limited to the problem domain of spacecraft mission operations. We want people to take the framework and do lots of other kind of cool stuff with it as well, ideally. So my reasons for talking tonight are sort of twofold. First of all, I thought you guys might be interested in seeing what NASA's doing with Angular. I have sort of an ulterior motive, which is this being an open source project, we want to try and recruit developers to sort of volunteer a little bit of their time to work on software, which is actually going to be used to fly, real NASA missions. So it's a tangible way for software developers to contribute to America's space program and exploring the solar system and cool stuff like that. So I'm going to talk a little bit. I'm going to start out talking a little bit about the problem domain of spacecraft mission operations and why this software exists and the problems that it's solving. I'm going to give a quick demo of the software so you can see it in action, see what I'm talking about. Talk a little bit about software design and some of the motivation behind some of the decisions that were taken there. I'm going to talk about Angular and where it fits in with our software and with our framework. And finally, a little bit about how everybody can get involved if they're suitably motivated and inspired by my talk this evening. So spacecraft mission operations. NASA missions typically have some sort of science goals, and those goals are met through spacecraft operations through multidisciplinary teams working together to achieve the science goals by so you have science users, you have mission planners. So these are guys who plan out in kind of finer detail what the spacecraft is going to do to meet its science goals. Then you have engineers who take plans and kind of make them a reality. So plans become eventually sequences of commands that are sent up to the spacecraft. And then the spacecraft is kind of constantly streaming back data about the state and the health of the spacecraft and its various subsystems. So you have commands going up to the spacecraft. You have a large amount of telemetry coming back down, and a spacecraft can have thousands of different things on it that are producing telemetry data, and they are updating, many times a second. So it can be quite a large quantity of data that's coming back down to Earth, and that data has to be interpreted by people to make decisions about the state of the spacecraft. So this is where it all sort of happens. This is mission control. I've got two pictures here I mean, most of you will be familiar with what mission control is and the concept and so on. I have two pictures here. The one on the left is probably the more familiar one. This is kind of the Apollo era, Apollo 13 sort of Gene Kranz era mission control setup. So it was a lot of analog displays, mechanical switches, those sorts of things, slide rulers, writing with hands in a crude, old-fashioned way. On the right, we have a more modern mission control setup. So this is what we have at Ames Research Center, and this is the Multi-Mission Operations Center. So the sort of mechanical switches and the analog sort of CRT screens and that sort of thing have all been replaced by software running on typical desktop machines, basically. So a typical operator sitting on console will have a number of different screens in front of them with a number of different pieces of software that they're using simultaneously, and they're switching between them. Their focus is moving between these different pieces of software. Where telemetry data is displayed to the user, it's typically in a fixed layout. It's shown in a particular way, and that can often require, in order to change that, if they want to customize that, can often require configuration changes or software developers to get involved, and so on and so forth. Mission control teams can often be geographically distributed as well. So they're not necessarily just sitting in one place. They can be spread between different mission control rooms around the country. So one of the missions that we're working on, we will have spacecraft operators and users of our system here in Silicon Valley. We'll have people at Kennedy Space Center, out in Florida at Johnson Space Center, in Houston, etc. And we'll also actually, because it's going to be an international mission, so the mission I'm talking about is Resource Prospector, which is a lunar rover. So that's one of the missions that's going to be using Open MCT. It's an international mission, so we'll have users potentially outside of the country as well. So I mentioned, I sort of touched on some of the challenges that OpenMCT is trying to address. I mentioned the fact that they're often working with multiple different pieces of software and context switching between them, and that has some cognitive kind of cost associated with it. We want to try as much as possible to bring things under one roof into a common kind of user interface to reduce the amount of context switching that's necessary. We also want to try and empower the users of the software to a certain extent to be able to build displays that kind of show them the information that they need, not just for their position on console, so that everyone in a mission control center has a particular role. So we want to be able to build displays that are useful for a particular role, but even for a particular task. So one of the use cases for OpenMCT is sort of anomaly analysis. So looking at data after the fact, after something happens on the spacecraft, going back through it, going back in time. So you want to be able to build a display that can pull together telemetry data that's relevant to that particular subsystem and that particular event. We want users to be able to see information in a way that's useful to them. So we support displaying telemetry in different ways. So you might want to see it as a plot or a table. You want to see it as a table so that you can kind of export it to CSV or something like that. Or you might want to see it as like a gauge that just shows the most recent value. So we want to put that in the hands of the users, basically. We want to support multiple platforms and multiple form factors as well. So that particular requirement guided the decision to make this a web application to a certain extent. We want to be able to pull in data from different types of data, so not just telemetry data, but also scheduling and planning information, and be able to visualize that alongside telemetry data. And we want to pull in telemetry data from multiple different sources. So you could potentially use this in a multi-mission scenario. So looking at data from more than one spacecraft, you could look at data from an active spacecraft and compare it to engineering data to compare sort of predicted versus actual values. We want to make it extensible and customizable as well, so that every mission is typically unique in some way. Otherwise, there wouldn't be a reason for it to exist. It's typically doing something new. It's typically flying, new sensors, often new hardware, different bus configurations, and so on. So it needs to be customizable. I'll talk a little bit more about that in a moment when I talk about the software design a little bit. And from the outset, we wanted it to be open source as well. The reasons for this are twofold. It makes it easier for people to pick it up and use it, even within NASA as an organization itself. NASA can be good at times at putting up barriers that prevent working between even just different NASA centers. So being open source, it makes it easier to allow other people to use it and to collaborate on the software. And we can also draw on the kind of skills and talents of the open source community and the enthusiasm of people out there to contribute their time and expertise to the project, which is great. I am going to briefly demonstrate the software to you now. And I'm going to go big. So looking at this screen, it's sort of roughly divided up into three areas. So you have on the left, there's an object tree. An object in this case is kind of a fairly broad concept, but it's not like a software object, although it has some similarities. But it's a thing that can be represented in the system in Open MCT. There are broadly speaking, there are sort of two different types of objects. There are things that produce telemetry, and there are user-created objects. So those user-created objects might use telemetry-producing objects, might compose them into a display. User-created object is something that can be persisted and shared with other users. In the middle, we have the visualization of the currently selected object, and there are typically multiple visualizations for a single object. I'll come back to objects in a minute and show some examples, and hopefully it will be a little bit clearer what I mean. On the right is some metadata about the selected object. I might actually so you guys can kind of see a little better what's going on. So I mentioned these two different types of objects. So you have sort of telemetry producing objects, and you have user creatable objects. These in this live demo, we have a mixture of sort of mocked data that's not real. So some of this real-time data here. So this is an example of what real-time data coming from a spacecraft might look like. This isn't actually real. So this is an example of an object that is representing some telemetry-producing subsystem on the spacecraft. We also have, and these can be sort of visualized in different ways, and I'll show you that in a minute. Essentially, there's raw data coming out of this, and then with different visualizations, you can present that data in different ways. We also have a number of user-creatable objects. So these are things like, for example, sort of Gantt charts and planning tools that can be used for planning the activities of the spacecraft. And the other sort of major type of user-creatable objects, user-persistible objects, are composed objects. So I might just jump straight to sort of layouts here. So at the top of the screen here, I can create a new object, and I'm going to create a display layout. So a layout is a composition of multiple different objects brought together in one screen. So as an example, I'm going to create a layout for somebody who's driving a rover. So first of all, they probably want to be able to see what the rover is seeing. Diving into the telemetry objects that are available, I'm going to grab one of these navcam objects and drag and drop it into the layout. I'm also interested, if I'm driving the rover, I'm probably interested in the state of charge of the battery, for example. So I'm going to go and look for a battery sort of state of, sorry, that's voltage, that doesn't matter. Grab voltage and state of charge. Just drag them in there. So this is kind of real-time data coming down off the spacecraft, but I can also, if I'm driving the rover, I probably want to know what activity the rover is currently supposed to be doing, what activities are coming up. So I'm thinking ahead. So I can bring in planning tools as well. So we're mixing different types of data, different types of information that are coming from different sources. So the real-time data is coming, that's telemetry from the spacecraft. I've got a planning tool here, which is a user-created, user-persisted object. I'm probably also interested in sort of the mission elapsed time and other things. So let's drop that in there. Default size doesn't need a little work. Okay, and once that's persisted, once that's created, I can persist it. And once it's persisted, I can then share it with other users of the system as well. Someone who's operating a spacecraft in real time would typically not be composing a layout in this way. They would be pre-composed ahead of time, and there would be change management and so on for these sorts of things. You don't necessarily want a real-time operator of the spacecraft changing things on the fly. But it is useful to be able to empower kind of groups, teams of mission operations specialists to be able to build displays that are useful for them without having to change, software configuration and write new code and so on. So far, I've been mostly showing streaming telemetry. Another sort of use case for this software is looking at telemetry data after the fact. So doing sort of a temporal analysis of spacecraft data. So as an example of this, I've put together a display which is showing some real science data from the Curiosity rover. So this is weather data, basically. You've got kind of air temperature and ground temperature and atmospheric pressure and so on going on there. This data can be explored using we have a user interface element at the bottom that allows you to change the date range that is used for querying the data, essentially. So this is data going back several years. So actually, you can see seasonal changes over the years here on the temperatures in Gale Crater on Mars. So this is 2 and a bit years worth of data. So you can see the temperature fluctuating over with those seasonal changes. But I can change the period that I'm looking at, like so, and kind of zoom in on areas of interest. We also have sort of marquee zoom and other sort of more intuitive ways of doing that for individual plots. Okay, so that's pretty much what I wanted to show of the software so far. So this demo, I should add, is online. This is a public demo. You can go and play around with it. I'll give you the URL at the end for the website and for our GitHub repository, so you can go and take a look at this as well. So I'm going to talk a little bit about the design of the software and some of sort of the motivations behind why we did things the way that we did. Open MCT is essentially it's a collection of plugins. The application core itself is a collection of plugins. And using the same means that we've sort of built the application, you can build plugins to extend it to do additional things. And the main motivation for sort of taking this approach is that when you're building software or hardware at NASA, there are often these two kind of slightly dichotomous requirements. I mentioned earlier that every mission is different. So every mission requires some sort of customization, new components. But at the same time, NASA is sort of a famously sort of risk-averse organization. So if something's going to fly on a mission, they want to assess the risk of flying that component, because there's typically quite a lot of money involved in a spacecraft. So balancing these two needs can be a little bit difficult. And what we hope to do by making it sort of a modular plugin-based system is limit the risk just to the. So basically, you will have an application core which has flight heritage and is proven, has flown missions. And when you're creating a ground software for a new mission, you can fill those capability gaps or those customization needs just by building new plugins. So you limit the risk just to the plugins that you're building. And we hope also to build sort of an ecosystem of plugins and have people sharing them, so that as much as possible you're using software that has flown missions previously. So we sort of try to achieve this by basically exposing extension points. So these are our API exposes a number of these extension points that allow you to do things like creating new object types. So I showed a couple of different object types there. I showed like a timeline, a Gantt chart. I showed a display layout. I showed telemetry objects. They're different types of objects. If you need something that's not provided by the core platform, you can create it by extending the object type extension point. We support extending the platform to display and visualize data in new ways. So data, a view, where it's typically called a view, is an extension point in our API. You can build adapters to bring telemetry in from different sources. So there are different standards and formats that are used for telemetry data. So you can build adapters for that work with these different standards and talk to different kind of endpoints and so on to receive your data. You can define new persistence adapters. So these user creatable objects that I've shown you, and user preference options and so on, they get persisted to some sort of persistence store. And we support a number of different persistent stores out of the box, but if one of them is not supported, you can build an adapter to support it relatively easily. And also we have extension points for defining new kind of user interactions and ways of working with objects in the system. So a little bit of code. The way that I've got, there's two kind of blocks of code here. They're basically showing the same thing. We're in the process of changing our API. The code on the left is the current API, and it essentially takes a declarative approach to defining your plugin bundles. So a bundle is how a plugin is defined. A new plugin is defined, and a bundle is essentially a collection of Angular templates, source code defining controllers and services and so on, as well as more platform specific entities like the telemetry adapters and views that I mentioned, and so on and so forth. And these are, a bundle is then tied together with a bundle descriptor file, typically called something like bundle.js. But it's essentially defined via configuration. as JSON objects, essentially. So as an example here, I'm extending the types extension point, and I'm defining a new type called folder. So that's the first code block there on the top left. Key is folder, name is folder, features creation. That just means that it's a user creatable object. It will appear in the create menu. Some description, and then I'm defining a view, so a way of visualizing this new object type that I've defined. And it has a key and a name, etc. I can point. So basically, the visualization will be implemented with some sort of HTML view. So then I link to it there, template URL. So that can be like an Angular template. I should say as well, when I talk about Angular in the context of this talk, I'm talking about Angular 1 because that's what we've been using to this point. And then I'm defining a gesture, so I'm saying that this view supports the drop gesture. So that means that some wiring and provision will be provided to the developer within their view to receive an object, an Open MCT object via the drop gesture when it's dragged from the menu on the left. At the bottom, I'm saying that this view is applicable for this object type, so type is folder. So I won't go through the code on the right, except to say that it's doing the same thing, but in a more kind of imperative fashion. So we found that based on developer feedback on our own kind of experiences of working with the platform, we found that the approach on the left meant that you had to read a lot of documentation to try and figure out what the different configuration options were that were sort of available to you. It wasn't necessarily the most natural way of working. The approach on the right is when we're using more sort of function calls and so on, so you can document the API more naturally using sort of JS doc and things like that. You can leverage, IDE support for JS docs to explore the capabilities of the API without having to dive into a lot of documentation. You can do runtime analysis of the API to see what's available to you and so on. So Angular was adopted. So the project's been going for a couple of years now, and Angular was adopted from the outset, partly for a number of reasons, which are sort of listed there. It uses sort of industry standard design patterns. Angular is kind of prescriptive about how to build a web application, which can be good, especially with sort of an open source project, because it means developers have a tendency to do things in a certain way because the framework prescribes that to a certain extent. It was selected because of its data binding capabilities. So data binding, saves development time and direct DOM manipulation and so on. Provides form validation and other things out of the box. Support for testing. There's less of a maintenance burden compared to if we had to build all the capabilities of Angular ourselves into the platform. So how do we use Angular? Angular is really core to the application as it currently stands. And in fact, if you want to extend the application and build new plugins, it imposes a requirement on extension developers to do things the Angular way, essentially. We're shifting away from imposing that requirement on extension developers for reasons that I'll go into in a minute. But one of the reasons that it does impose that requirement on extension developers is that we use Angular dependency injection fairly heavily. So Angular DI sort of ties everything together in the application. So I showed you briefly before this one of these bundle configuration files. This is another example of bundle configuration on the right. And here I've highlighted two Angular kind of components. No, components is an overloaded word now. But Angular entities. In this case, I'm defining a controller and a service, and then I'm tying them together via sort of Angular dependency injection. So Angular components like controllers and services are defined in the same way as other non-Angular entities in the system, and then they're all tied together. The non-Angular entities are sort of become sort of Angular managed objects, and they all kind of get tied together via Angular DI. This can make it perhaps slightly awkward for Angular developers who know how to define a controller and know how to define a service in the Angular way, and then they have to sort of figure out how to define them in the Open MCT world. So that's another reason for kind of getting away from this declarative bundle configuration style and removing the sort of imposition on extension developers, plugin developers to use Angular. So they will be free to build plugins that work with Angular 2 or React or whatever the hell they want to use, or vanilla JS. But in essence, so there's provision within the platform for defining Angular entities like controllers and services and directives and so on and so forth, alongside the platform-specific entity types within the bundle definitions, and then they're tied together with Angular DI. We use data binding extensively, directives very heavily as well. So I wanted to talk about kind of a couple of sort of lessons learned that came out of our experiences of working with Angular 1. And I've touched on some of these already. So the first one is that based on feedback that we got from developers, they didn't necessarily want to have to learn Angular in order to work with Open MCT. Everyone has their own kind of preferred frameworks, and we don't necessarily want to limit people to just using Angular if they don't want to. So we're in the process of refactoring our API so that it's framework agnostic. You can do things your own way if you want to. It could be a little difficult to integrate with non-Angular components, and obviously there are ways of doing this in the Angular world with directives and so on. But you have to know Angular in order to know how to do that. So this was another kind of motivation for removing the external requirement on AngularJS. I should emphasize that we continue to develop our core application and all of the views and user interface elements using Angular. We're just removing the requirement to use it for developing plugins. Some of our views have working with a large quantity of data that has to be refreshed on the screen very rapidly, and data binding could cause sort of performance issues at times. So we found that in some cases, and partly these were architectural issues of our own as well. But we learned to use data binding judiciously and minimize the number of watches that we were creating. Standard, I guess, kind of best practices. So what's the future of our platform? We haven't made a decision. Well, we haven't adopted Angular 2 yet. We may adopt that for the core application. As I said before, we're not imposing Angular on plugin developers. We're removing that imposition from the API, but we're continuing to build with Angular in our core capabilities. If anybody wants to get involved, that's the GitHub repository URL and the website below it, so you can find out a bit more about the project on the website. I mean, you can get coding straight away, so long as you have a GitHub account. We have a bunch of help wanted issues, so you can go on there and pick something that looks interesting to you. Yeah, that's it. Thank you very much.
Thank you, Andrew. Hey, everybody. Igor is here. Steven had to go home. So we're going to do Q&A now. I will ask Steven to come here and feel free to ask questions. So let's try to focus the questions on the presentations that we had today. If you have other questions, we can address them after we address these questions about the presentations. I have a mic, and I think we have a few more mics. Let me check on that. In the meantime, if you have a question, please raise your hand. A question over there, just a moment.
I don't see anything. No, I don't see anything. I believe it.
Hi, my question is about Augury. I do have routes defined in my application, but I don't see the router tree. I don't know what I'm missing. Is there anything you need to do in the application or in the config to make sure Augury works perfectly?
And you're using, well, I guess, have you injected into the root component, the
Yes.
router?
Yes.
And it's called router?
Sorry?
The component instance property you injected in is router?
Yes.
Then it should work. Yeah, I'd say, close the developer tools, give it a refresh. That's what I usually do. But I'll give it a look right now if you like after these questions.
Right.
Yeah.
A question in the back.
This again on Augury. So normally when we sort of deal with some debugging tools, we would like to see if it can actually help us debug rather than analyze our application. Augury is great in terms of we seeing our application and us seeing what are the different components, what are the different routers, and sort of trying it out. How would it help us in case of errors, which Angular 2 is good at reporting, but at times becomes tough to deal with?
You're saying what could Augury do to help give you insight about errors that are occurring in the application? Well, what we can do is look at the configuration and try to detect things that are probably not intended. So that's our thoughts so far. But I mean, if Angular's going to throw an error, then I mean, I haven't heard anyone suggest so far that we should kind of contribute or help out in any way in that situation, because Angular is telling you already. But if you have any ideas, we're going to hear them. But yeah, it's not something that's come up so far. We really are just thinking so far about, I mean, me in particular, I'm thinking about, since we're looking more and more at the configuration, we can kind of tell if things are imported just redundantly, for example. We can tell that. So we can clear things up. That might lead to less errors, just because we can detect, hey, you probably didn't expect, or you didn't intend to do this. But that's more the line that we're thinking so far. But yeah, if you have any suggestions, yeah, you can get in our Slack, everyone. We have a Slack. Anyone wants to chat, jump in there, get an invitation. So yeah, bring it up with us for sure. If you want to talk to me after this, totally.
Thank you.
Nice. I can't see any hands, but.
Do we have more questions?
Oh, look, there are.
So is there any plan to bring Augury within the IDE?
As in to provide IDE kind of features in Augury?
I mean, yeah, within the IDE kind of plugin or something like we have on the Chrome.
Oh, you mean in an IDE have an Augury plugin?
Yeah.
To just, instead of you doing it in the developer tools.
IDE layer, right?
Well, I mean, that's kind of in the same line as just with the native script support, the possibility of pulling it out of there, making it available, served on a port somewhere, that can kind of be considered the same thing or in the same vein. So it's not something that's been talked about concretely at all, but that direction is something that we're looking at because of native script support. So I'm not sure it's totally of the advantages, if that would, would that be really advantageous to have that integrated into an IDE as well? I'm not so much of an IDE man, I guess.
Yeah, depends.
I don't want to have everything bundled into one, Eclipse. But yeah, again, yeah, let's say if you have a good, feeling about that, bring it up with us. We're willing to have any conversation. For sure. Thanks.
Question to Andrew. With all the different visualization tools that you have, all different plugins, do you standardize on some particular library or set of tools like Material Design or Bootstrap or Kendo or something like that?
So we have a dedicated sort of in-house UX expert. So all of our UI elements are kind of built from scratch, essentially. We don't, in terms of visualizations, there are some that we use in certain cases. So like we're using D3 for some stuff, but most of it is built from scratch because quite often it has to be fairly highly optimized for the kind of display rates and so on that we need to support.
Chrome Tools already does a good job on the styles and changing them at element level. Would Augury consider some features or tools around the styling like NG style or even NG class type of things, analysis and things like that? Feature.
Not sure exactly what you're asking, but a way to just to change on the fly.
On the fly, yeah, the same way Chrome Tools does it at element level.
I mean, I haven't considered that. I mean, it hasn't come up, but I would consider. My first thought is that because the Elements tab does such a good job of that, that would be a huge job to implement that with. Yeah, I guess we probably. Yeah, I would say that's not in the direction that we want to go. Just because it's such a small team that we really have to pick our features wisely. Although it sounds like it'd be nice to do everything through Augury as well. But yeah, I feel like I'd have to have a clear advantage of it, doing it through the Elements tab.
Right.
Thanks.
I'm curious to know, what do you wish that Angular would make available or provide instrumentation for that you could get to that you can't currently get to with Augury? When you're here at Google, Igor's right here. You could just ask for it.
Yeah, well, I have a bi-weekly call with Igor, so I'm going to leave him alone tonight. But don't worry, I'm waiting on an email response right now. No, yeah, I mean, there's lots of things with these last couple of features that actually I don't know if there's anything outstanding, there's improvements we want to make. But I think, I mean, my next thing is that bat scanner being able to hook into the lifecycle events of components easily without requiring any change to the application. That'd be really, I mean, it would allow us to do all of that. And if you check out bat scanner, bat scanner, that's quite impressive UI. So, I mean, really helpful insight into the application. Performance-wise, you don't see that unless you don't really understand that until you see it visualized. So that would be a great feature. And yeah, I don't know a way to do that offhand yet, or if that's possible. I'm sure it could be if Igor decided. It was, where is it? Oh, sorry, it's right there. Sorry, my eyes. But yeah, it's that's the next one. Yeah. Thanks.
Other non-Igor questions? No more questions? Really? Well, thank you, everybody. Oh, one more question. Okay, last question, I guess.
My question is to Andrew, related to your tool that you're building for NASA. Probably it's expected to be very stable and very robust during work. How you deal with such expectation with web application? Are you doing anything special to profile it or deal with memory leaks on? Like, for example, it's supposed to work for a long period of time in the browser, and
yeah, we don't use any particular tools or libraries or anything like that for dealing with that sort of thing. I mean, NASA has fairly stringent software standards anyway. So we adhere to the usual kind of NASA software standards. We have, I guess we have provision within our testing for picking up things like memory leaks. So we leave it we will leave the application running with multiple tabs open and check memory usage beforehand and afterwards, and after sort of activities are carried out and so on. At this stage, we're sort of still in a somewhat experimental phase. We're sort of moving towards a more kind of production-ready system and still building out the processes for doing that, for like automating that sort of thing. So at the moment, it's fairly manual. So we're not using any tools specifically for that kind of thing.
Okay.
Yeah.
Got it. Thank you.
Cool. Any more questions? With that, thank you, Stephen and Andrew. Thanks for coming.
Thanks, guys.
We'll
Thanks
be
a lot.
hanging around for a few more minutes. If you have any more questions, you can come and ask. Thank you for coming. When you're leaving, please help us clean up this space so that we can enjoy it next time. It's very much appreciated. Thank you. Bye-bye.